So I thought this seemed like quite a interesting puzzle. It's called What an Odd Sight by Damo89. So normal Sudoku rules apply. Place the digits 1 to 9 in every 3 by 3 box, in every column, and every row. Now, a digit in a circle is odd and counts the number of odd digits that can be seen in all orthogonal directions combined, including itself. Even digits block the view. Okay, so on Logic Masters, it mentioned the name in brackets parity sight lines, right? So that's the term for this, parity sight lines. A digit in a square is even and counts the number of even digits that can be seen in orthogonal directions combined, including itself. Odd digits block the view. All circles and squares are given. Okay, that's also quite important. So what this basically means, let's look at this one for example. This is an odd digit, and its value is going to represent how many other odd digits it can see in all orthogonal directions combined. So that's going to be this direction, this direction, this direction, this direction. But even digits block its view. So it's given that the squares are even. So it can't see any of those squares. It can, at this moment in time, see all of these. But if there were, for example, an even digit here, let's say that was a 2. Let's say this was a 5. Let's not worry about this with regards to it being a clue right now. Let's just see it as an odd digit. Let's say that's a 3, and let's say that's a 4. Now this would have to be a 3. Well, yeah, it would have to be a 3. So let's just make that maybe make that a 7. Okay, it's an odd digit. That's an odd digit, and that's an odd digit, and it can see all 3. So this would be a 3, right? That's all that is telling us. So let's get started with this. I think this is going to be quite interesting. Okay. So I'm looking, I think this is a good place to start. 3, 5, 7, or 9. Now 9 is not going to be possible, right? Because at most, if all of these were odd, it would be 7. It already sees at least 2. Okay, let's do this one as well. Now for this one, I would think 9 is possible. Well, what is the maximum? It's 9. But for this one, actually, it can't see 9 because you'll only get 9 if the circle can see every single odd digit in its row and its column, right? And in Sudoku, there are 5 odd digits and 4 even digits. So it would see all 5 in the row, all 5 in the column, but itself would be counted twice. So it would be 9 distinct odd digits. But this can't be 9 because there's only space for it to see at most 4 digits in its row, 4 odd digits. 2, 4, 6, 8. Now 8, an even digit can never, these can't be 8. Because there are only 4 even digits, and remembering that itself gets counted twice in the row and column, the most would be 7. This one already sees 3, including itself. I want to actually color these in. Orange for odd, blue for even. Okay. 1, 3, 5, 7. This one, 9 is possible. 2, 4, 6. Okay. 3, 3, 5, 7, 9. I mean, 1, 3, 5, that'll be 1, 3, 5, 7, 9, 1, 3, 5. I think these are pretty much all 1, 3, 5, 7, and 9. I don't think any of them are restricted at all. No, this one can't be 9 because it can only get at most 3 from its column. So if it were to get all 5 from its row, it could get 7. It can still get 7, right? Okay. 2, 4, 6, and 8. 2, 4, 6, and 8. So 8 is somewhere here. This one can't be a 9 because of what we said earlier. It can only get 4 from its row, from its column at most. So 8 and 9 are outside over there. 3, 5, 7, 3, 5, 7. Okay, so what do we do now? 2, 4, 6. How can this be 6? That can't be 6. It can only be at most 4. Okay. 4, so yeah, so if that's a 4, then that's a 6. These all become even. That gets those. So it sees 4. It needs to see another 3. 6, and then this would have to be 4. 1, 2, 3. So if this was even, then this would see 4, and this would see 3, which is a problem because it needs one more. So then I would do that. Now this sees 5, so now it needs to see one more. So then I make one of these even. Right? Let's say I make this one even. It doesn't matter, I don't think, because we're just looking at these. So now this sees 6. 1, 2, 3, 4, 5, 6. This sees 4, and this now sees 3. So then I have a problem, because so I can't put one there because then I've used up, I've already used my quota of even digits in this box. And if I put one there, then this one also sees it, and now that would have to be a 7. So that doesn't work. What about if we had put the blue here? Well, now this sees 6. This sees 3. So then I would have to put one there. And now it would see 4. So that works. Right? 2, 3, 4. And then these have to all be odd. Wait, but this was 4. So there's a problem. The problem is just that because they're all next to each other, they're sharing a lot of cells, and specifically these two. any more that I add to the row will be seen by both of them. What, right? Like if it's seen by one of them, it's seen to both of them because it means that it's contiguous. So I don't think this can be a 6. Because for this to be 6, I need to add too many such that these can't be a 2-4 pair. It's no ways. Okay, so this is a 4. That makes that a 2. That makes that a 6. So this one is done. So we have to cap it off with an odd cell. This one is done. This one needs one more, either there or there. This one needs a heck of a lot more. It only sees 2. Now, only one of those 2 cells can be even, right? So, how do I make this 6? 1, 2, 3, 4. But now this sees too many. So I can only add, this is just how you think about it. I can only add one more to the row. And then I have to add 3 to the column, like this. And because I need to add 3 to the column, I can't add another one to the row on that side. I add it on this side. And then these are odd. So it's kind of cool. You build it up and then you cap it off with the opposite parity. So I'm going to say it has to be like this. Now that's 4, 6, 4, 2, and the world makes sense. And this becomes an 8. And that, oops, that is odd. And these are all odd just because I'm counting the number of evens that we've used. Okay, now we know this is not a 3 anymore. It's 5 right now. This is also, this is not a 3 or a 5. That's a 7 or 9, but we know there's a 9 here. So this is a 7. 1, 2, 3, 4, 5, 6. So it needs one more. These are even. Just going off the fact that we've used our quota of odd digits in this box. So this, it needs an odd number to be in one of these positions. It needs an odd number in one of these positions. Okay. 1, 2, 3, 4, 5. So no. So if I put one there, it would solve this problem and this problem. 4, 6, 8, 2, or 8. The 8 came out from there. This is a 9. Well, actually, we don't know what that is. 9. No, we have no idea what that is. I don't know why I'm trying to pencil mark that. These are all odd. Those are all odd. This is 6 and 8. This is 2 and 4. Now what's this? Well, it's at least a 5, and it can't be a 9, because it's separated from this one. So it cannot be complete in the sense that it sees everything in its row and column. Five or 7. So for it to be 5, I would have to put an odd digit here. Wait, what about this one now? 4, 5. 5, 7 pair. 5, 7 pair. Okay. Well, look, it's at least a 5, so this has to be odd. It needs to be, at least that one has to be odd, and maybe these two, right? Because so now it sees 5. If it sees 7, then those are also odd. We don't know, but we know that one at minimum has to be odd, and these are even. And now this 7, 5, 6, it needs 1 in one of these two spots. 3, 4, 5, and that will complete it. So these two are even. Six, 8, 2, 4. 4 is a problem. Wherever the 4 goes, we need another even number adjacent to it. Because otherwise, we'll be violating the negative constraint. And it would have had to have been a square 4, because it sees 4 even numbers. Here's a problem. This sees 5. For it to see 7, I would have to color in both of these. But then it sees 8, because it joins onto this one. So it can never be 7. It's 5 and 7. These two are odd now. This is even. This is even, to cap them off. To cap off the 5 and to cap off the 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. This is 1, 3, and 9. 1, 3, and 9. So 3 is currently in danger there. If I did put a 3 there, I would need another odd. Well, we know there is going to be another odd digit in one of those positions because of the 7. So 3 is fine. Now this one sees at least 3. Oh, this became a 7 by Sudoku. 1, 2, 3, 4, 5. It has to grow in this direction. 1, 2, 3, 4, 5, 6, 7. And then this has to grow. Okay. 1, 2, 3. So, yeah, 4, 5, 6, 7. Those both have to be odd. makes the rest of the row even. We'll come back to that. And now this one cannot be 3 anymore. It sees 4. It needs 5. It can only grow in this direction. And it can't be 7 by Sudoku, so it is 5, and we cap it off. And that becomes even. This sees 4 at the moment. This is a great puzzle. This is a really cool puzzle. 8. Wait, this is not a square. This is not a square 8. Never mind. We need one more odd number. 5. This is 3 and 9. 3 and 9, which means this is a 5. And 3, 9, 2, 4, 6, 8. Okay. 1, 2. This became even. We're doing well. 3, 9. So this one is quite restricted now. This is 103. That is 103. And what is this one? This one is also 103. Right? That one's also 103. Wait, so wait, but this box is already full. So it's not 1, this is 3. That's the 3, this is the 1. So we place, so we have to do this. 1, 3, 9. How do you 9, 3. Are those safe? Yeah, those are safe. I know that negative rule is, it's going to come up sooner or later. Maybe later. 1, 2, 3, 5, 9, 1, 7. This is odd. That's odd. These are all odd. I'm just looking at what we've filled up. One of those are even and one of these are even. This is even. So that sees 2 now. This sees exactly 2. So that cannot see 2. We'll come back to that. We'll come back to that. Oh no, it sees 4. Okay, goodness. I thought we had made an error there for a second, but I think it's fine. 6 and 8. I thought, oh no, it only sees 3, but it sees 4. We're fine. That is seeing 1. That is seeing 3. This one, well, these are even. So it's picking up 4. This will have to be odd, right? So that it becomes a 5. 1, 2, 3, 4, 5. Okay, we've nearly done all of our clues. I think this is the only one left. The 4 came out there. There's a 2 or a 6. 6 or 8. One of these has to be the 1, so that's not a 1. One of these is a 1. It's not that one. Okay, let's see if we can just do a bit more coloring. Oh, this clue we also haven't done. Don't see any more opportunities to color in. This became a 2, I missed that. What is this? Is the 2. Okay, let's look at this. Now, this already has... This noise is just going to be a 6. Okay, I think that's obvious. It has to be the 4 because we only have 1 more to spare in the column and 1 more to spare in the row. So at best we can do that, and that will give us the 4. And that will give us the 4. Okay. So that's quite straightforward. And then this becomes the 6. This has to be the 8 actually, so that's the 2. And this is a 6, which makes that the 8, that the 6. Okay. 6 goes here then, so that's the 8, the 6. 8 goes here. That's 4 or 8. Okay, and then these are odd. Odd, odd, odd. 1 or 7, 3 or 9, 1 or 7. 3, 5 or 9, but 5 is not there. Okay, these are odd. Okay, so we have a couple more evens to place here. Actually, we have 3. So this is probably not going to be very high. And this one, basically, we can't connect it to these 2. So we're looking at 1 or 3. Well, it's not 1, obviously. So it'll have to be 3, because it can't be 5, because then I would need to do this, and then it would be more than 5 anyway. And it would be, well, I mean, it doesn't matter, because I can't do that. So we have to do that one to make it 3. And then that is even. And both of these are even. And that is odd. And that is even. All right. So there we have completed our puzzle. I mean our clues, all of our clues. 3, 5, 3, 9, 3, 5. So now it should just be a matter of playing Sudoku. Should just be a matter of playing Sudoku. So 1, 3, 5, 7, 4, 8, 4, 8, 4, 8. Okay, so that is the 6 then. 2, 8, 2, 8, 2, 8, 4, 8, 2 or 4, 2, 4, 6, 8, 6, 8, 4, 8, 4, 8, making that the 6, making that the 8 the 6. I thought that was going to do something more. Okay, 2, 2, 4, 6, 8, 4, 4, 8, 6, 2, 4, 2, 8, 4, 8. Wait, what did I do? Yes, 8, 2, 8, 4, 2, 4, 2, 8, 4, 6, and 4. And we were done with the even numbers. Very good. Okay. Odd numbers, I suppose, are a bit slower since there's more of them. So let's have a look. Let's have a look if there's anything easy. Well, this is a 1-3 pair. 1, 7, 5, 7. We might have to think of our rule, our negative constraint rule. 3, 7. Ugh, I don't like where this is going. Let's do it like this. Ones. I don't see anything for ones. 3s. 3s. Come on, lucky number 3. That's a 5. Is that a 7? Fives. Yeah. Yeah, it's not a great experience with that. It's not working very well for us. Yeah. 9-7. Looks like that's a 9-7 pair. Making that a 1. Making that a 1. This is a 3-9 pair. This is a 7-5 pair. This must be a, whoops, this must be a 1-9 pair. This is a 9, 5. 591913. Yeah, we're gonna have to think about the rule, I think. Let's see. We need to be more conscious. This one, look at this. Right there. That can't be a 5. Because then if it was a 5, because all circles are given, it would have to be a circled 5 because it sees 5. 1, 2, 3, 4, 5. Okay, so that's a 9. And that's a 5. And that's a 7. And that's a 5. Good. Okay. That's the only place for a 5. Only place for a 7. Three, it's safe. 3 is safe to put there. Okay. 1719 79 1717. Okay, so I'm making sure that all of my numbers are in pairs. Which just helps me to check that I didn't do something stupid and I didn't notice a number somewhere. Okay, 3. What about this one? 4, 5, 6, 7. That can't be a 7. It's a 1 and a 7. 1, 7. 7. This is a 1, a 9, a 1, a 3, a 1, a 9, a 3, 9, 3, and 7, 9. We're done. Cool puzzle. Really, really cool puzzle. You know, I saw on Logic Masters it had a rating of, I think, 99% from something like 200 solves. So it seems like people are just loving it. Thanks so much for the puzzle demo. 89 was great.